Parallel universes, often known as the multiverse, coexist with our own in literature and movies, and they might be anything from minor changes in events to completely separate laws of physics. It is an intriguing and exciting concept. Physics researchers have given the possibility of parallel universes considerable study, and they have developed a number of theories. One widely accepted theory is predicated on a fact that physicists are already aware of: the universe is expanding. This indicates that distant galaxies are moving away from Earth. We refer to this phenomenon as cosmic inflation. Additionally, the universe is expanding more quickly the further away from Earth you are. The cosmos is expanding too quickly for light from certain extremely distant galaxies to ever reach us at some point. This implies that the universe has a limit beyond which we are unable to see. However, that does not imply that there is nothing there. Beyond this boundary, there are yet more galaxies, but we will never be able to see them. Beyond this border, some physicists believe there is a separate, parallel universe. This theory is well liked because it doesn't call for any novel physics or revisions to how we currently perceive the universe. The possibility of several instances of cosmic inflation supports yet another notion concerning parallel universes. The theory holds that there was widespread inflation immediately following the Big Bang. This led to the expansion of distinct universe bubbles, and occasionally particular forms of matter ended up in one bubble rather than another. This implies that in some bubbles, the physical laws governing how things operate may be different. Even though they are isolated from our universe, each bubble is nevertheless unlimited in size. This theory intrigues physicists because it could explain why we haven't discovered some objects that we would expect to see in our world based on science. This also applies to magnetic monopoles, which are magnetic fields with a single positive or negative side. They might rather be in another bubble of the multiverse. The final theory calls for us to consider a branch of research known as quantum mechanics. The main focus of quantum mechanics is the likelihood of minute particles acting in a certain way. A small particle shot at a wall may bounce off of it or pass through it. Quantum mechanics tells us which event is more likely. However, there is nothing in the maths that says that only one of the events must occur. Both of these things might happen at once. But we would only see one of these things happen. So, if you saw the particle bounce off the wall, it might have also, at the same time, tunneled through the wall, just in another universe, not our one. In the many worlds theory, there is plenty of room for another Earth. Each quantum reaction on our planet would create another parallel universe with another Earth. The other theories, such as those of the limitless expanse and universe bubbles, present more complex issues. There is a possibility that the exact same kinds of events repeated again in another bubble or somewhere else in the vastness of space to produce another Earth if there are infinite universe bubbles and endless space. When you do the maths, though, it quickly becomes unlikely. For just 1,000 particles to interact in exactly the same way twice, the chance would be 1 in 10 to rise to 2,477. The number 10 rise to 2,477 is a 10 followed by 2,477 zeros, which is an incredibly big number. There are far more particles in the universe than 1,000, so the chances for another Earth are not in our favor. Unfortunately, we don't know if these parallel universes exist. Or at least, we don't at the moment. Physicists are trying to find ways to test these theories, but it is very difficult. For now, they remain just theories. But who knows, perhaps scientists in another universe have already figured it out. If you liked this video, consider subscribing.